Hey, good trash day morning, neighbors. Black coffee again. I don't know if it's working or not. I didn't make it till an hour after I was up, hesitating if I even wanted it. No milk and sugar. And it's just different. So, did a video yesterday about PV equals T. It's a pressure equation, it's a volume equation, it's a temperature equation, depending on what you're trying to solve for. But I didn't picture it is in that form, in that simple form. It is called an ideal gas law, meaning it deals with a single gas in a vessel or a container or a defined space, not a mixture of gases. That is so hugely important. And then I ignored, because I took for granted you can take this into fluid dynamics and make it useful in any type of moving systems. It's an amazing equation, PV equals T. It's like E equals I times R. Is that the one? P. So there's a bunch of them that look like that out there. They have the same general form. It's almost as if they're the same species. But you take those things into calculus. You take those equations into calculus where you can do summations. You can do Riemann summations of quantities. It's akin to why we can only get halfway to absolute zero or halfway to infinity. That's the closest we can get to these things now until we invent another way of looking at things. But that's in an absolute world, and we live in a relative world. We're related to the sun, we're related to the earth, we're related to each other. So that PV equals T, that equation, PV equals nRT, there's even more to it, has some things going on. And I didn't explain N or R. And I got them wrong when I did just speak past them. So it gets very complicated. Because I'm thinking of summations. I'm thinking of total actions of systems, not the singular action. But you have to understand the singular actions inside the system to be able to do summations of the system. It is related to herd theory. It is advanced calculus and statistics and stochastic and game theory and a myriad of other things that have proved to fit and model our existence. It's the realm of supercomputers. A person thought of this Riemann sum thing. Another person thought of PV equals T for an ideal gas, a singular type of gas. A good reference is the noble gases that don't interact with anything. Neon, xenon, argon. So others, elements are very reactive, but some don't react with it, they're just there. They exist. And then other elements are very unstable. Hydrogen is one of those because it's a fundamental property of many other elements and likes to play with all of them. So, there's a PV equals T, just made infinitely more complicated. You can apply it to seismic movement, to geology, to the crustal movement. You can apply it to the ocean's flows. You can apply it to the atmosphere. Then you can go further in the interactions of the earth and the oceans and that contact point and the heat exchanges. You use this little equation in there, a sum of hundreds of those little equations running on a supercomputer, multivariant real-time analytics. It really is pretty cool stuff we do already, and hard to explain. So there's another tack, another approach to PV equals T, and how easy it is to try to make it too easy in under 6 minutes. ebb and flow of the tides. Or we could use vector physics. I've pointed and poked at that as well.